Okay, so let's consider this example here. Um, sums k starts at 3 to infinity of 2 over 2k minus 1, 2k plus 1. This, on the surface, initially does not look like a telescoping series. Does not look like a telescoping series, right? Because a telescoping series requires us to be subtracting two things. But one thing that kind of hints to us that it might be a telescoping series is the fact that we, once again here, uh, have things that are kind of in sequence, right? 2k minus 1, if you plug 3 in, that's going to be 6 minus 1 would be 5. 2k plus 1 would be 7. So this is 5 followed by 7. When you plug in your next value, 4. 2 times 4 is 8 minus 1 is 7. And then 8 plus 1 would be 9. So you do have this kind of behavior that's still, a sequence of integers, except instead of being, uh, things like 1, 2, 3, 4, 5, now these are actually going up as pairs of odd integers, 5, 7, 7, 9. The next would be 9 and 11, and so on. So that gives us kind of a little hint that this might be a telescoping series, that there's a chance, but it certainly isn't clear in the current format. So just to see what's going on here, my first few terms of this sequence would be 2 over 5 times 7, 2 over 35, plus 2 over 7 times 9, 2 over 63, plus 2 over 9 times 11, and so on and so forth. So looking at the terms of the sequence, again, we also don't see, at least from that it in any way looks like a telescoping sequence. But a telescoping series requires us to have a difference. And right now I have a fraction, but I have it in terms of two denominators. So what we can actually do here, in the hope of getting it into the format that would fit a telescoping series, again, we don't know for sure that it is one. Okay, it is, but you wouldn't know for sure when you first encounter it that it is one. But what we can do is use something from the past to rewrite this as two separate fractions. And so in other words, we're using our partial fraction decomposition here. Okay, so we're doing our partial fraction decomposition. And then we're going to hope that this is going to be something where it's a minus between the two. So we can then hopefully evaluate as a telescoping series. So we're really at this point hoping. So remember how to do partial fraction decomposition. Once we have it decomposed, we multiply through by the common denominator. So on the left-hand side, we'll just have a 2. On the right-hand side, we're going to have a times 2k plus 1. So that'll be 2ak plus a. And then b times 2k minus 1. That'll be plus 2bk minus b. And that leads us to a real basic system of equations here, equating our coefficients. 2a plus 2b has to be equal to, well, there are no k terms, so that would be 0. And a minus b has to be equal to 2. All right, so you would solve that system. It's not a very complicated one to solve. I'm just going to tell you that a is 1 and b is minus 1. And you can do a quick check to see that that works. 1 minus a negative 1, 1 plus 1 would be 2. 2 times 1 plus 2 times negative 1, 2 minus 2 would be 0. Okay, so, but that's a pretty easy one to solve, so I'm just not going to bother with that step. So now I can take my series and say, hey, we can rewrite that original series 2 over 2k minus 1, 2k plus 1 as the sum as k goes from 1 to infinity of a over 2k minus 1, 1 over 2k minus 1, and b is minus 1, so that's minus 1 over 2k plus 1. And that is the format of a, I said k equals 1, my sum is actually k equals 3. So stay with the original limits, those won't change. Okay, and so that is the format of a telescoping series. And so we start looking at our terms to see what's going to happen here. So what are our first few terms? Well, k equals 3, 2k minus 1 would be 5. So that'll be 1/5. 2k plus 1 would be 7. So it's actually 1/5 minus 1/7. And then it would be plus 1/7 minus 1/9. And then plus 1/9 minus 1/11. And so on and so forth. And we notice that the successive terms do cancel out quickly here, right? 7s cancel out, the 1/9 cancels out, the 1/11 would cancel out on the next one. So because they are happening successively, I don't have to backtrack as much as I would have to if there was a gap between them. So of course the 1/11 will cancel with the next one. And so the last term of this sequence would be n. So we'd have 1 over 2n minus 1 minus 1 over 2n plus 1. And the sequence would continue. And so we know that term there would have canceled out with the 1 that came before it, the 1 over 2n minus 1. That would have been the last term from the one right before it. And so the partial sums then would look like this. Sn would be 1/5. Sn would be 1/5. And then minus 1 over 2n plus 1. And so then we would do the limit to find out what the sequence converges to. The limit would be, as n goes to infinity, of Sn. And of course, as that happens, 1 over 2n plus 1 goes to 0. So we have 1/5 minus 0. And so this thing is actually going to converge to 1/5. This thing is actually going to converge to 1/5. Okay. And so that's another example of a telescoping series. And this time we got to leverage some of our old stuff. Partial fraction decomposition came up as a use there.